Wow, hey everyone. Super excited to be here. Kind of nervous. I would love if you could help me, because it's once in a lifetime opportunity for me. So if you guys can join me for a quick selfie, so we can get this going. What do you think? Gonna catch some of you here. Smile. Awesome. Wow, thank you. So hi, my name is Zohan. I'm a team lead at Mixtiles. And we're gonna talk about face detection today. Woo! Super cool. I looked at some of your faces. I already detect that you're super hungry. Don't worry, we'll keep this one short and sweet. Speaking about sweet, how sweet is it when you finally solve an issue that really bothered everyone in your company and your customers? We at Mixtiles, we did just that, and I hope you guys also got to experience it. Today we're gonna, but now we've had some hard-taught lessons. And today we're gonna talk about those lessons. I'm gonna share with you. And we're gonna talk about what was the issue that really bothered our customers, how did we end up solving it by iterating over solutions, and what does face detection have to do with anything? We're gonna dive into some code, and by the end of this 15 minutes, I hope you will know how to use face detection on the web, and also feel inspired to use it in some of your projects. Let's begin. So to talk about the problem, we have to first talk about Mixtiles and what we do in Mixtiles. We help people create homes they love. One of our biggest products is the photos. Tiles, you know, those ones that you stick on your wall. And we try to make this a great user experience from the moment you open the phone all the way to when you stick it on the wall. And we're gonna show you that experience right now so you can understand the problem. This is the actual website, and I preloaded some photos. What users can do is, and what they usually do is they upload multiple pictures at a bulk, and they can choose frames like this. They can change the frame. They can use effects like so. And they can even change the orientation. But there's another key component for a great photo, a great tile, which is the crop. For example, look at this photo. We have a couple of young ladies, but some of them got cropped. And I'm sure those two on the top will not be happy. And this is the issue we were facing. Because users don't take the time to crop each picture individually, they get what we call a bad crop. So these are examples of users who actually got a bad crop on their tile. I'm sure you would not be happy if you got this product. And they were complaining. They were complaining to customer support. Around 15% of customers who complained about a bad crop. And the reviews went down. For a B2C company like Mixtiles, reviews is one of the most important metrics. And when you see it go down, it's something that you really need to take care of. Okay. So one developer suggested using a machine learning algorithm to create a smart crop. And what is a smart crop? Imagine you have a machine learning model that detects objects in the scene, and then you can adjust the crop accordingly. And that crop should produce the best crop. It should work on low-end devices because most of the users are using mobile, and it should keep the current user experience as great as it is. And we start to talk about it, and we start to experiment, and we got to Tensorflow. So Tensorflow is a library by Google. It allows you to run machine learning models on the web using WebGL, which means every device that can use a GPU can run it. And it's really cool. It's made of tensors. Tensors are multi-dimensional vectors, and you can flow the data in to create models. You can train models, and you can use pre-existing models with TensorFlow. And we tried it. It was great. We found this is how we would do it: object detection. It would know to recognize books, landscapes, animals, and all that. We tried it. We saw that it was easy to use, but the problem was that it was taking time to load, a long time to load, and it's super heavy. The model for detecting objects is 5 megabytes. It's not something we can actually use. We said, okay, there's a problem. There's got to be something we're missing. And then it dawned on us. In Mixtiles, we deal with happy people, families, couples, cute puppies. 90% of uploads are humans. If we remove all the objects and we only focus on faces, we can really speed out our process. And then we got to use Face API.js. Face API.js is a library that uses TensorFlow under the hood, and it's really, really good at detecting faces and much more. Let me show you some examples. So this is our lovely people at Mixtiles, And what we can do is we need to basically choose a face detector model, and we are offered two models. We have the SSD mobile net, which is a heavy one. It weighs around 5 megabytes as well. It's really good at depicting pictures. And we have the tiny face detector, which is 200 kilobytes, which is less accurate, but it's all about the trade-offs. And what you can do is you can draw detections. For example, this one recognizes the faces, and you can see the confidence level. It's more, and you can really load the limit, so only take the ones where you're super confident are people. We can draw facial expressions, like happy. Everyone's happy here at ReactNext. And you can draw landmarks, which I know it's a bit creepy, but it's great for building filters. So that's really awesome. Let's look at another example and see. Here, you can see that it detects surprised, sad, happy, and somewhat angry, but also mainly neutral. And now the question is, how do we use it in code and in React? Because this is what we came for, right? We'll begin with the use face API hook. So use face API models hook. We load it at mount, and let's focus on the effect. It comes here. Basically, when it loads, you load all the models, and we chose to load 3 models: tiny face detector, face landmarks, we want to know the landmarks, and face expressions. And we put all these models at a public folder called models, but you can take them from a CDN. And that's it, they're loaded. Now, how do we actually use this hook? Let's use an example. We have a simple component wrapping an image. So we wrap an image, we have a reference to that image, and we have a hook for it. And that hook only runs when A, the models have been loaded, and the image is ready. And now we're ready to do some face detection. Let's dive in. I'm gonna move this mouse a bit so you will see. So with Face API, you can detect all faces, which this is what we're gonna do. You can also detect a single face, and it accepts an image, and it accepts a face model. We saw tiny face, but we also have the SSD one. But we loaded other models, so let's also add face landmarks and face expressions. Now we have an array of face detections, but what do we do with the data? Let's show it on an image. We're gonna add a canvas to it. Here we basically think about it. We had an image, now we're putting it in a container, and we have a canvas or invisible canvas on top of it. Now Face API will help us take that canvas and make it as big and wide as the image. And now we are ready to do some things, and we have some data. We don't have to deal with canvas and how to draw it because Face API helps us do that as well. So all we have to do is Face API draw detections, give it the canvas and the detection it found, and it puts those detections on the canvas. And we can draw face expressions, and we can also draw the landmarks that you just saw. But there's a lot more things we could do with Face API. You can find gender and age. You can run it on video, real-time video. So just think about the possibilities and how simple it is and how you can also do it yourself. Really worked well for us. We found out that it's specialized in faces, and it does it very well. And if we choose the tiny model, it's comparatively small to the big one we had in Tensorflow, so it's 200 kilobytes compared to 5 megabytes, which is a big change. This is Shaul. Shaul is my friend from the Shuk Carmel. This is actually a picture into the future because I'm going straight there after this talk. And I want to put this lovely man and myself on this tile, and I want to put it on my wall. So how did we do it before? We had what's called a center crop. Naively, we take the center of the picture, and it becomes the focal point of the crop. And so we can then put it on a tile. Okay, a decent result, but notice that the center is my hand, and it's not the most beautiful thing in this picture. Shaul is. How do we make it better? Well, now we have the smart crop. Smart crop, we detected the faces, and it's not enough for us to just detect the face. We interviewed people and we saw how they build and they crop their images. So we thought up about this algorithm. We take the faces and we add a bit on top because it only takes the face, right? We have to take the whole, everything. And we found out that usually if you take half the face, it's a good amount. And then we combine all the rectangles into one, do a union, and this becomes the focal point of the crop. So we create the smart crop from it, and we put it on the tile. Amazing. Now we have our face in the center, everyone's happy, and we're good to go. You might think it's okay, it's subtle, but not really. First, let's talk about, let's see, all those people that really were mad. How would it look now with the smart crop? Now their faces are in the center, and I wouldn't imagine they're gonna complain and resend those tiles. So again, this is how it looked before, naively with our solution before, and this is how it looks now with the tile. What about performance? So performance, what we got is, we first have to load the model, which takes around a second and a half. We then, every detection costs a few milliseconds, and eventually calculating. The crop is static, it's nothing. So on the first time it might load slower, but then it becomes extremely fast. Well, the results talk for themselves because customers were super happy. We saw a lot less people complaining, a lot more repeating customers. We don't have to send tiles back again. So eventually, and all this translates into money. We went through our analytics and we saw that this feature alone made us around $6 million a year, which is not bad for something, for one feature. But it's not all unicorns and rainbows and smiles, because we have some improvements to do. First, it doesn't work on images without faces. What happens, and those account for roughly 10% of Mixtiles photos. What do we do with them? How do we create a crop with those things? So that's something we're dealing with. And if we go with the tiny model I showed you, it doesn't detect some faces. So maybe we have to figure out dynamically which model we want to load. And then for users with high latency, we might load the bigger one. And it does have an impact on bundle size. Let's be honest, 200 kilobytes, relatively small, but it's still a lot. So we are now looking for ways to optimize that. And let's be honest, also we're looking at generative AI solutions. DALL-E, ChatGPT. ChatGPT still doesn't take input of images, but once it does, and eventually it will, we're definitely gonna be there to look at it and then check the possibilities. So before we wrap up, I'm gonna talk to you about what we did today. We talked about the problem that we suffered at Mixtiles, how customers were complaining, and really putting bad reviews, how we iteratively try to solve those issues, and we came closer to the solution every time, which led us to face detection. And you got to see how to use face detection yourself, and how we use it in Mixtiles. If you like what we do, and you're creative, and you want to solve problems in a creative way, feel free to talk to us at Mixtiles. We always love to hear from you guys. And if you want to build something cool, let me know at Twitter. I am at Hagafny. I would love to see what you do. Thank you very much.